The Argument Clinic. Causes and consequences. If two things happen, how can we know if one was caused by the other, or if one is the consequence of the other? Here's an example. I bumped my head this morning, and now I've got a headache. Are these two facts related? They might be, or the headache might be due to having a very demanding voiceover schedule. So, how do we make sense of this kind of relationship? A correlation is a statistical test that shows whether two variables are related to each other. Do students who attend lectures do better in exams? To test this, we could collect data on 100 students' exam marks. The results might look like this. We can see that when the attendance rate is higher, the marks are higher. This isn't true for every student, but it's a general trend. But the existence of a correlation doesn't mean there is a causal relationship. It could be that more motivated students both turn up to more lectures and study harder, and that's why they get better results. All we can say from the data is that there is a relationship, but not whether one event was consequent upon another. How can we dig deeper into our data and find out what the underlying cause is? Mistaking correlation for causality. The fact that there is a relationship between two things does not mean that one has caused the other. Suppose we compare your likelihood of getting sunburn with the amount of coffee you drink. Suppose we find that people who drink 4 or more cups of coffee a day report fewer incidents of getting sunburned than people who drink less coffee. Does that mean 4 plus cups of coffee protects against sunburn? It hardly seems very plausible. Much more likely is that higher coffee consumption is associated with working in an office environment. That is, indoors, away from the sun. These two events are related to a third variable, sunshine, but they aren't directly related to each other. Even if a real relationship between two things makes intuitive sense, it can be difficult to define a causal relationship. Which is the cause and which the effect? There's a correlation between alcoholism and depression, but does alcoholism cause depression? Or depression cause alcoholism? Or are they both caused by some independent third factor? Fake causality. It is also possible to manipulate data in order to manufacture correlations to back up a political or social argument. A common trope in the mainstream media is that video games cause violence. This tends to pop up when there is a tragic event, such as a mass shooting. We might see headlines like, "Teen plays Call of Duty and kills classmates. After night playing video games, boys cause chaos in mall." Juxtaposing the two events in a single headline implies that one caused the other. What isn't factored in is that an extremely high proportion of young people, more males than females, play violent video games, and almost every one of them does not commit mass murder. The headlines could equally be, "Teen eats toast for breakfast and kills classmates. After cleaning teeth, boys cause chaos in mall." Even if you could prove a correlation between playing violent games and acts of violence, it would be impossible to imply a direction of causality. Does playing games cause violence? Or are people who are more predisposed to violence more likely to play violent video games? Coincidence. If we look for relationships in large data sets, we will find many correlations just because of random chance. These can often be quite entertaining. For example, there is a striking year-on-year correlation between a number of people who are injured in swimming pool accidents and a number of films released starring Nicolas Cage. Think about whether it makes sense for one thing to be related to another, and then whether direct causality is a possibility. Then we can look for ways to test the relationship. To prove causality, a good approach is an experimental strategy known as a controlled study. We start with a hypothesis. We might hypothesize that a dependent variable is caused by an independent variable. We might hypothesize that a new reading method, independent variable, will cause an increase in children's literacy, dependent variable. We would then design an experiment to test this. We get a class of children to be taught with the new approach for a term and then test to see if their literacy has improved. If reading skills have risen, can we conclude that this was caused by the new reading method? Not really, as there could be other factors that have caused this improvement. This particular class could simply be stronger across all subjects, for example. To address this problem, we need to use a control group. To see if the new method is really causing the improvement, we need another group that is as similar as possible to the first, apart from the way that they are taught. One group, known as the treatment group, is given the independent variable, in this case the new reading approach. Our second group, known as the control group, is not. We can then compare the differences between reading skills for both groups, and if the treatment group's skills are significantly higher, it would be reasonable to conclude that the improvement in reading skills was caused by the new method.
What do you say we cut the chit-chat?
See the controlled experiments video in this series for a more in-depth discussion of this. Something to think about. Remember to think about whether one thing could have caused another, or whether the causality might work the other way around. Could they both be caused by a separate factor? Could the link simply be a coincidence? When you're reading the paper or watching the news, think about implied causality. Are two events being linked together in a way that implies that one caused the other? Do they present any genuine evidence to back this up?